So today we will be learning insertion sort. It is a very easy and basic algorithm in which we divide our array into two parts where we assume one part to be sorted and one part to be unsorted. And then we select the first element of the unsorted part and insert it inside the sorted part, and we continue this for the complete array to complete our sort. So in the first step of our insertion sort, we assume the first element at index 0 to be sorted, and we assume the rest of the array to be unsorted. Now we start selecting from index number 1. So we have card number 3 over here. Now we compare this to the elements of the unsorted array which is over here. Now since 3 is less than 4, we compare these two and then you swap them. At the next step of the sort, we go to this element, which is of the first element of a new unsorted array. Then we compare this to 4, since this is less than 4. We compare this to 3, since this is also less than 3. We shift these two elements over here and take 2 over here. Now a new unsorted array is element number 3, element at index 3 and element at index 4. So the element at index 3 is 2. Now we compare this to the elements of the unsorted array. So 2 is less than 4. It is less than 3. It is not less than 2. So now what we do is that we shift this part of the sorted array and we move 2 over here. Now one thing that we need to notice over here is that in our original array, this 2 was towards the left of this 2. The red 2 was towards the left of the black 2. So this, and even in the final array, the final sorted array, we see that this 2, the red 2, is still towards the left of the black 2. This means that insertion sort is a stable sort, which simply means that if two elements are equal, then the order in the unsorted array is maintained in the sorted array as well. So finally we have our last element at index number 4. We compare it to the last element of our sorted array, and since 5 is bigger than 4, we leave it over here. And this is a final sorted array from the insertion sort. Now we come to the complexity of the insertion sort. So if we have only one element in our insertion sort in the array, then since this array is already sorted, t of 1 is equal to 1. Now for any t of n, we need to understand that this is equal to t of n minus t of n, where n is 5 over here. T of n is equal to t of n minus 1 plus n minus 1, because the final card, the final element, you will be comparing this to all n minus 1 elements. From this we figure out that t of n is equal to t of n minus 2 plus n minus 1 plus n minus 2. This is basically solving the recurrence relation. Now we can observe that the recurrence relation is solved by finding t of n to be to the order of the summation of n by observing over here. So because the summation of n is equal to n into n plus 1 by 2, we figure out that t of n is the order of n square. So the time complexity of insertion sort is of the order of n square.